In 1930, Schenectady, New York, was home to 95,692 people. One company had put most of them there. One company had built the rail lines that threaded through the city's core, the research laboratory that produced the first Nobel Prize ever awarded to an industrial scientist, the radio station that was among the first to broadcast in America, and the generators pushing electricity into homes from the Atlantic coast to the Pacific. By the time of the Second World War, that one company employed 45,000 people within the city limits, nearly half the entire population on a single payroll behind a single gate on Erie Boulevard. Today, a few thousand work where 45,000 once did. The population stands at 67,047. The gate is still there. This is the story of what happens to a city that hands its fate to a single corporation, and what that corporation does with it. Chapter 1. The City That Lit the World. Schenectady called itself the city that lights and hauls the world, and in the years between the two world wars, that phrase was not promotional language. It was an accurate description of the planet's electrical infrastructure and of the machines moving freight across an American continent. The light in your parlor, the engine pulling freight over the Rockies, the turbines turning in the Navy's warships. A startling portion of all of it originated within a few square miles of the Mohawk River, in a city that most Americans could not have placed on a map without help. Not a metaphorical center of production, an actual one. A single city, with a peak population that never quite touched 100,000 people, that housed the headquarters and principal manufacturing works of General Electric, and 2 miles away on the same river, the largest plant of the American Locomotive Company. 2 industries, 2 giants, 1 city. The slogan was not an exaggeration. It was, for roughly 4 decades, a clinical description of where the modern world's lights and freight engines came from. The Mohawk River made it possible, the way rivers made most things in the American interior possible before the steam engine arrived to rearrange the logic of geography. Schenectady sits where the Mohawk Valley opens toward the west, the last natural way station before the valley narrows into mountain country and the routes diverge toward the Great Lakes and the Ohio, and the vast agricultural interior of the continent. The Mohawk was the corridor. The city was the gate. When the Erie Canal was completed in 1825 and threaded directly through Schenectady's center, connecting the Hudson River to Lake Erie across 363 miles of dug channel, it confirmed what the Dutch traders who founded the settlement in 1661 had understood from the beginning. This particular bend in this particular river was where things passed through. That geography could be taxed, warehoused against, built upon. And so it was. The canal era passed, displaced by the railroad, which arrived with its own logic of routing and its own requirements of coal and steel and labor. What it left behind was a city already accustomed to being a transit point, already organized around the movement of goods, already populated by the mechanics and laborers and merchants that industrial transit requires. When Thomas Edison moved his electrical machine works up from New York City to Schenectady in 1886, he did not choose an empty field. The infrastructure was there. The labor was there. The rail connections were there. And Schenectady businessmen and bankers pooled their own money, $7,500, to close the difference between what Edison's people had offered and what the sellers were asking, because they understood, collectively and without prompting, that the company Edison was building was the kind of thing a city should not let pass through to somewhere else. That instinct was correct. It was also the founding condition of everything that would follow. The extraordinary growth and the extraordinary dependence and the extraordinary collapse. A city can benefit enormously from staking its identity to a single company. It can build that company's workers into its schools and its churches and its sense of what a stable life looks like. What it cannot do, in any arrangement that history has yet produced is guarantee that the company's interests will remain aligned with the city's indefinitely. General Electric did not arrive in Schenectady in 1886 to benefit Schenectady. It arrived because Schenectady was useful. Those two things, being useful to a corporation and being served by it, can look identical for decades, until the day they don't. The structure of what happened here follows the two-industry frame the slogan encoded. General Electric lit the world. Generators, turbines, research laboratories, light bulbs, radio broadcasts, the first industrial Nobel Prize. The American Locomotive Company hauled it. Steam engines in 150 configurations. The Union Pacific big boys assembled in Schenectady and shipped west to pull freight over the mountains. 2 payrolls, 2 factory gates, the fathers and sons of nearly every family in the city working one or the other. When one pillar came down first, the locomotive works, shuttered in 1968 after the American Railroad switched to diesel. The city still had the other. When the other began its long withdrawal, there was nothing left to reach for. The gates on Erie Boulevard are still there. Keep that detail in mind. Chapter 2. Beyond the Pines. Arent van Curler was a Dutch-born trader and colonial administrator who had spent the better part of 2 decades managing the affairs of Rensselaerswyck, the vast patroonship the Van Rensselaer family had carved out along the upper Hudson River in the 1630s. He knew the Mohawk Valley the way a man knows a corridor he has walked 100 times. Its flood rhythms, its soil, the trails the Haudenosaunee had maintained for generations, through the pines, towards that pressed close to the river on both banks. In 1661, he led a small party of Dutch settlers west along the Mohawk to a broad flat of alluvial farmland where the river bent north, and established the settlement that would become Schenectady. The site had fewer than a dozen European structures when the first winter closed in. The Mohawk had a name for this place before Van Curler arrived, and kept it after he left. Schenectady, beyond the pines. The phrase is a directional description, a geographic coordinate expressed in relation to a tree line that marked the edge of what was knowable to those approaching from the east. Beyond the pines was the Mohawk Valley opening toward the Great Lakes and the Ohio country, and the continent's vast agricultural interior. Van Curler understood this. The settlement he planted was not an endpoint. It was a threshold. The Mohawk held Van Curler in a regard that outlasted him. They called him Corlaer, their rendering of his name, and the name did not retire with the man. For generations afterward, the Haudenosaunee addressed the governors of New York by that name as well, not because they confused them with Van Curler, but because Corlaer had become, in their diplomatic vocabulary, the title for whoever occupied the seat he had first held. A title worn, in the end, by men who never knew the Dutch administrator who invented it. What made Schenectady possible also made it exposed. The settlement sat at the edge of defensible territory. It had a stockade. It had a gate. Neither proved sufficient on the night of February 8, 1690. King William's War had been running for nearly 2 years. The North American theater of a European conflict translated onto this continent into a series of raids across a frontier too vast to hold cleanly. A war party of French soldiers and their native allies came south from Montreal in midwinter, on snowshoes, across a frozen wilderness that the settlements had assumed no force would cross in February. The assumption was the vulnerability. The party arrived outside Schenectady's stockade in the early hours of that morning. The gate was open. Accounts differ on whether it had been left open deliberately, carelessly, or by some failure of the watch, but the result was the same. The raiders entered without resistance and burned the village to the ground in a night. The raid killed all but roughly 60 of the inhabitants. The survivors returned to the same ground and rebuilt, not nearby, not on higher, more defensible terrain, the same flat of alluvial soil beside the same bend in the same river, for the same reason Van Curler had chosen it in the first place. The geography that made the place a target also made it too valuable to abandon. The Mohawk River was there. The corridor west was there. The farmland was there. The massacre became the founding myth's dark interior. The place had been destroyed once and had returned, which meant it could survive being destroyed. It survived, and for the next 135 years it grew. Slowly, steadily, the way a trading post grows when it controls a corridor. The Mohawk Valley became, in the 18th century, one of the main arteries of British colonial expansion westward, and Schenectady sat at its mouth. The frontier pushed west, and Schenectady ceased to be the edge of it, became instead the hinge between the settled Hudson Valley and whatever was building itself further along the river. And then, in the autumn of 1825, the Erie Canal arrived. Not arrived as a metaphor. Arrived as 363 miles of dug channel running directly through the city's center, connecting the Hudson River to Lake Erie in a single navigable line. The canal passed through Schenectady because the Mohawk Valley was the only natural break in the Appalachian ridgeline through which a level water route to the interior was possible. Geography again. The same valley that had made the Dutch settlement possible and made the 1690 massacre possible now put Schenectady at the center of American commercial movement at scale. Goods poured through. Population followed. A frontier trading post was becoming a transit hub, and a transit hub, positioned correctly, with the right rail connections and the right labor supply, was exactly what a man like Thomas Edison would look at 60 years later and see what he needed. The pines were long gone by then, but the position remained. Chapter 3. The $7,000. The first great Schenectady industry arrived in 1848 before General Electric, before Edison, before anyone in the city had heard the word electricity used to describe something manufactured. The Schenectady Locomotive Engine Manufactory opened that year beside the canal and the new rail lines threading through the valley, and it began doing what Schenectady's geography had always suggested it should do. Building the machines that moved things, locomotives, steam engines that would carry the city's name on iron plates across a continent, pulling freight and passengers over the Alleghenies and the Rockies and the long, flat miles of the interior. The canal had made Schenectady a waypoint. The locomotives made it a source. For nearly 4 decades, the locomotive works was what Schenectady meant industrially. A city of machinists and iron workers, of furnaces and rail lines, and the noise of a factory district running at capacity. It was a serious industrial city. It was not yet an extraordinary one. The population in 1886 stood at roughly 13,000, a working city of modest size on good geography, waiting for the industry of the next century. In 1886, Thomas Edison made a decision that his accountants preferred to see made elsewhere. He needed to move his Edison Machine Works, the manufacturing arm of his electrical business, out of lower Manhattan, where land was expensive and expansion was impossible. He wanted rail access, canal freight, cheap land, and room for buildings that had not yet been imagined. He found a 10-acre parcel in Schenectady, a former locomotive plant site, the McQueen Works, that sat exactly where those requirements converged. The owners wanted $45,000. Edison's people had offered $37,500. The gap was $7,500. And on that gap, the negotiation had stopped. What happened next is the founding act of everything that follows. A group of Schenectady businessmen and bankers, none of them named Edison, none of them working in electricity, none of them with any claim on the profits the new company would eventually generate, looked at the $7,500 gap and pooled their own money. They raised the difference. They handed it across and closed the deal. Not as an investment in shares, not as a loan with interest terms, as a subsidy from a city to a company that had not yet decided to belong to it. The price was $45,000. The city paid $7,500 of it. Edison paid the rest. For that, Schenectady got roughly 200 workers, 2 unfinished factory buildings on a river parcel meant for locomotives, and a man whose name appeared in the newspapers more reliably than any inventor in the country. What it got in the longer measure, what those businessmen were betting on, collectively and without a written return, was the manufacturing core of American electricity. The math looked improbable. $7,500 for an industry. The math was exactly right. By 1900, the population had passed 30,000, more than double what it had been when Edison's workers arrived. A frontier mill town in one decade, a company town in the next. Workers moved into the houses nearest the plant. Merchants followed the workers. The city was learning something new, what it looked like when the thing you made was not a product that passed through, but a company that stayed. In 1892, that company would take a new name. But we are getting ahead of ourselves. Chapter 4. The Company is Born. On April 15, 1892, the Edison General Electric Company merged with the Thomson-Houston Electric Company of Lynn, Massachusetts, to form the General Electric Company. The transaction was engineered largely by J.P. Morgan's banking house, which had concluded, with the detachment of men who think in capital structures rather than inventions, that two competing electrical manufacturers spending their money fighting each other over patents and market share would be worth considerably more combined than separate. The merger created the largest electrical manufacturing company in the United States. The main works were in Schenectady. Thomas Edison was not its first president. The man who took the title was Charles Coffin, a Massachusetts-born shoe manufacturer, verify birthplace and prior industry, who had built Thomson-Houston into a company formidable enough to absorb the Edison operation in everything but name. Coffin had no background in electrical engineering. He had a background in running organizations, in managing production at scale, in the unglamorous administrative work of turning invention into reliable output. Edison was a phenomenon. Coffin was an executive. General Electric, it turned out, needed an executive. Under Coffin, the Schenectady plant did not merely grow, it swallowed. The original 10-acre parcel Edison had purchased in 1886 expanded block by block, year by year, pressing toward the Mohawk River on one side and Erie Boulevard on the other, until the works occupied a contiguous stretch of the city's riverfront that read, from above, less like a factory complex than like a second city installed inside the first. Its own internal rail lines ran between buildings. Its own power stations generated the electricity the plant consumed. Its own fire brigade. Its own foundries. Not a factory on a river, but a complete industrial organism. Those gates were the fact from which everything else in the city radiated outward. Tens of thousands of workers passed through them every working day. Not a figure of speech, but a daily human procession that the city organized itself around entirely. The boarding houses nearest the gates filled first. The streetcar lines ran to the gates. The downtown merchants timed their hours to the shift changes. The city's economic metabolism was keyed, with startling precision, to the rhythm of those gates opening and closing. What the plant produced in those years was nothing less than the physical infrastructure of American modernity. Generators, turbines, motors, transformers, arc lamps, and the incandescent bulbs that gave the city its nickname, the Electric City. The generators went into the power stations appearing in every American city of sufficient size. The transformers made it possible to move electrical power over distances the early Edison systems had never managed. Schenectady was not manufacturing consumer goods. It was manufacturing the underlying physical layer on which the rest of American industry would come to depend. The wiring in the wall, before there was a wall. The company became the city's weather. Schenectady could no more control what General Electric decided than a coastal city can negotiate with the tide. When the plant ran at full capacity, the boarding houses filled, the merchants prospered, and the city built schools and parks and the civic institutions of a place that believed its prosperity was structural. When orders slowed, the whole system contracted in step. There was no second large employer to absorb the slack. The decision to pool $7,500 and bring Edison's works to Schenectady had been the right decision, and it had made the city entirely legible. One plant, one payroll, one gate on Erie Boulevard that told you, by the volume of the crowd passing through it, everything you needed to know about the state of the local economy. By the turn of the century, the plant employed tens of thousands. The company was not finished building, and it was not finished inventing. What it would build next was not a turbine or a transformer or a larger foundry on the riverbank. It would be a room full of scientists, paid to think, with no requirement to produce anything that could be sold in any given year. The company was no longer going to manufacture only products. Chapter 5. The Wizard. In 1900, General Electric established a research laboratory in Schenectady, the first industrial research laboratory in the United States. Not a testing room bolted to a factory floor, not a workshop where engineers refined products already in production. A laboratory. In the scientific sense, a place where men trained in chemistry and physics would pursue questions whose commercial application was not yet known. The argument inside the company's engineering ranks was that a corporation competing at the frontier of electrical technology could not afford to develop only what it already understood. It needed real science. Willis Whitney was 32 years old when he became the laboratory's first director. A chemist trained at the Massachusetts Institute of Technology, he built the laboratory not as a department of General Electric, but as something deliberately insulated from it. A place where a scientist could pursue a problem with no scheduled delivery date and no customer waiting for the answer. The pressure to produce something saleable in a given quarter was, by design, excluded. That was the invention. Not any single result the lab would eventually produce, but the institutional structure that made results possible. Corporate research as a category did not exist before Whitney built it on a Schenectady riverbank. The man whose presence defined the laboratory's early decades was not Whitney. He was Charles Proteus Steinmetz. Steinmetz was born in Breslau, Prussia. Verify exact birth details. In 1865. He was small, the result of a kyphosis, a severe curvature of the spine that left him with the posture of a man bent permanently toward the earth. The deformity was hereditary. His father and grandfather had both carried it. He studied mathematics at the University of Breslau and moved in the circles of the student socialist movement, pressing, in the 1880s, against the limits of what Bismarck's Germany would tolerate. When arrest became a realistic possibility, Steinmetz fled, first to Zurich, then, in 1889, to New York, arriving with little money and one of the finest mathematical minds in electrical science. Verify emigration circumstances. He was 24 years old. Within a year, he was working in electrical engineering. Within a decade, he was at General Electric in Schenectady, where he would spend the rest of his life. His formal title was consulting engineer. His actual function was something closer to theoretical oracle, the man the company's engineers brought their hardest problems to and waited for the mathematics to return in a form they could use. What he produced was not products, but equations. The symbolic notation by which alternating current could be understood, predicted, and controlled. Alternating current could be stepped up in voltage, transmitted over long distances, and stepped down again at the destination. The property that had won it the contest against Edison's direct current. But winning the argument was not the same as understanding the mathematics. In its early commercial deployment, alternating current was as much art as science. Engineers knew it worked before they could fully predict how it behaved under varying conditions of load and impedance. Steinmetz built the predictive framework, his symbolic method, formalized in papers and textbooks that engineers carried for decades, gave the industry the language it needed to design systems rather than merely extend them. Transmission line after transmission line, substation after substation, grid after grid, spreading across a continent, each one resting, at its mathematical foundation, on work done by a small man bent over paper in a Schenectady laboratory. He was known everywhere, not known the way a scientist is known inside a discipline, known across the country, in newspapers and popular magazines, the way a senator is known. The Wizard of Schenectady. He corresponded with engineers on 3 continents, kept unusual animals in his home on Wendell Avenue, and camped summers on a houseboat on the Mohawk River, verify houseboat detail. He smoked cigars without apology in every room he occupied. He died in Schenectady in 1923 of heart failure at 58. The room full of scientists had found its wizard. Chapter 6. The House of Magic. They called it the House of Magic. Verify. The name attached itself to the General Electric Research Laboratory the way a nickname attaches to a man whose accomplishments have exceeded the vocabulary his formal title provides. It was not a single discovery that earned it. It was the cumulative effect of what kept coming out of those rooms on the Schenectady riverbank. Year after year, decade after decade, inventions and theoretical breakthroughs arriving with a regularity that suggested the building itself was the cause. William Coolidge arrived at the laboratory in 1905, a chemist trained at the Massachusetts Institute of Technology and in Leipzig. Quiet in the way that men are quiet when the work has all their attention. He was 32 years old. The problem he turned toward first was tungsten, the metal that Edison had identified as the ideal filament for the incandescent bulb, hard enough to glow without burning, with a melting point higher than any other element on the periodic table. The problem was that tungsten was brittle. In its natural state, tungsten shatters. It cannot be drawn into wire. Coolidge spent 4 years solving the problem by solving a different problem. Not how to work with tungsten as it was, but how to transform it into something else. The process he developed, working the metal under heat and pressure through a sequence of mechanical reductions, produced what he called ductile tungsten, a form of the metal that could be drawn into wire of any thickness without fracture. The modern light bulb filament descends directly from that work. So does the Coolidge X-ray tube, developed next, a device that used a heated tungsten cathode to generate a stable, controllable beam of X-rays, replacing the unreliable cold cathode tubes then in medical use with something a radiologist could depend on. Introduced in 1913, the Coolidge tube became the basis of medical X-ray equipment in hospitals across the world. Coolidge would eventually hold more than 80 patents. He became the laboratory's director in 1932. Irving Langmuir came to the same building in 1909. He was a physical chemist, trained at Columbia and Göttingen, and his early work at Schenectady was directed at a question that seemed almost embarrassingly practical. Why did incandescent light bulbs blacken on the inside and burn out so quickly? The answer he established through precise experimentation was that the tungsten filament slowly evaporated in the vacuum, depositing metal on the glass. His solution was to fill the bulb with an inert gas, nitrogen and argon, which slowed the evaporation rate and extended the filament's life dramatically. Every household in America was eventually using the result. In 1932, he received the Nobel Prize in Chemistry for work on surface chemistry, built substantially from experiments conducted in the Schenectady building. He was the first scientist working in an industrial laboratory ever to win it. Not the first American, not the first chemist, the first scientist anywhere whose Nobel-recognized work had been done in the employ of a corporation. The laboratory produced discoveries. The company, in those same years, invented something subtler and in some ways more consequential: the media that would carry those discoveries and everything else into American homes. In February 1922, General Electric launched radio station WGY from Schenectady, one of the first licensed broadcast stations in the United States, operating on a 1,500-watt transmitter that could push a signal across a radius that dwarfed anything a newspaper had managed by geography alone. Ernst Alexanderson, a Swedish-born engineer who had come to GE in 1902 and whose high-frequency alternator had made transatlantic radio communication possible before the war, ran much of the experimental work out of the Schenectady laboratories. Alexanderson, Coolidge, Langmuir, 3 men, 3 disciplines, the same building on the same river. WGY went on the air, and the company that had wired the nation's walls was now filling the air above those walls. The lights were inside the house. The signal was everywhere. Then, in 1928, GE's Schenectady station transmitted what appears to have been one of the first dramatized television programs ever broadcast. A scripted production sent over the air years before most Americans had seen a television set or had any reason to believe they would. Verify. The exact nature of the broadcast and its claim to precedence remain contested in the technical literature, but the fact of it is recorded. Schenectady, again, first. The city that had lit the world and hauled its freight was now trying to put moving pictures into the air above it. All of this from one building, the House of Magic. It was the right name. Chapter 7. Lights and Halls. On June 24, 1901, the Schenectady Locomotive Engine Manufactory, which had been building steam engines on the same riverside ground since 1848, ceased to exist as an independent company. It was absorbed, along with 7 other locomotive builders scattered across the country, into a new consolidated entity called the American Locomotive Company. ALCO, as it was known almost immediately, established its headquarters and largest plant in Schenectady. It was the second largest locomotive builder in the United States, second only to the Baldwin Locomotive Works of Philadelphia. Verify. Over the span of its working life, it would produce more than 75,000 engines in more than 150 different configurations. Passenger locomotives, freight haulers, mountain climbing engines with extra driving wheels, specialized machines for mines and harbors, and yards too tight for standard equipment. More than 75,000 engines, and the largest share of them built in Schenectady, 2 miles from the gates on Erie Boulevard, where General Electric's workers were already arriving for the morning shift. The slogan was now completely true, not provisionally true, not aspirationally true, true in the way a chemical formula is true, as a description of what existed and how it worked. General Electric lit the world. Its generators fed the power stations. Its transformers stepped voltage up and down across the transmission grid. Its light bulbs burned in every parlor from Boston to San Francisco. The American Locomotive Company hauled it. ALCO's engines pulled the freight that fed the factories, the passengers that moved between cities, the mail and the timber and the grain and the coal that held the industrial economy in motion. The slogan was not a boast, it was a job description. What it meant for the city beneath the slogan was a totality that is difficult to reconstruct from this distance. A worker could spend 40 years at the ALCO yards, learning the floor of the erecting shop, moving through the specialties of the blacksmith trade, finishing as a foreman with iron filings in his beard, while his neighbor, across a fence, spent the same 40 years winding armatures for General Electric generators. Neither man worked for the same company. Both men's children went to the same schools, bought groceries from the same merchants, sat in the same parish pews. The two payrolls were the city's circulatory system, and in 1901, with ALCO newly organized and GE's research laboratory newly staffed, the whole of Schenectady was rising. Picture Erie Boulevard on a Thursday morning in October of 1929, the last October before the market broke, the last month when the peak felt permanent rather than precarious. The GE gates open at 6:30, and the shift change releases a river of men onto the boulevard that the streetcars cannot absorb all at once. Men in work clothes pressing toward the Proctor's Theater marquee, toward the department stores on State Street, toward the lunch counters and the barber shops, and the savings banks that had grown up in the years since the payrolls arrived, and made savings a thing working men in Schenectady could have. 2 miles east, the ALCO yards are in the same rhythm. The erecting shop in full noise, locomotives in various stages of assembly standing in the bays like iron cathedrals under construction, each one accumulating its driving wheels and its boiler and its cab over a period of weeks before it rolls out the door and down the transfer track to the rail connection that will carry it to whatever line has ordered it. The downtown is lit. The streetcar routes run from the GE gates to the ALCO yards and back through the center of the city in a loop that traces the perimeter of everything the two companies have built. In State Street, Wedemeyer's department store and Wallace's dry goods have their windows dressed for the season. The hotels are occupied by salesmen and buyers, and the engineers who travel the country for GE on technical contracts. The population that year stands just below the peak it will reach in 1930, 95,692, the highest number Schenectady will ever record. A tenfold increase from the city Edison's men had arrived in, built almost entirely on 2 sets of gates and 2 morning shifts. That number, 95,692, is the arithmetic of everything the two companies had built. General Electric, ALCO, the research laboratory, the radio broadcasts, the Nobel Prize, the ductile tungsten, and the alternating current mathematics, and the first television signal sent into the air, all of it, compressed into a census count on a single city on a single river. The grocery stores and the schools and the parks and the tax rolls that paid for them, all of it resting on the assumption that the gates on Erie Boulevard would keep opening, that the erecting shop would keep filling with locomotives, that the thing the slogan promised would remain true indefinitely. Chapter 8. The Arsenal. The war came, and the city became something it had never quite been before, a weapons factory. Not metaphorically, not by the loose logic that equates industrial scale with martial power, but in the direct and accountable sense. The generators, the turbines, the locomotives that Schenectady had spent 6 decades building for peacetime commerce, were now being built for the United States government under contract, on a timeline that the government set, for a customer that had no ceiling on its orders and no tolerance for delay. The gates on Erie Boulevard opened wider. The payrolls grew longer. General Electric employment in Schenectady swelled to roughly 45,000 people, nearly half the entire population of the city on a single payroll behind a single fence. The city had been a company town for 60 years. For a few years in the early 1940s, the company was running the city on a wartime schedule. What General Electric produced from the Schenectady plant was the propulsion machinery for more than 1,700 United States Navy warships, destroyers, cruisers, carriers. The turbines that drove them through the water were built here, or built to designs developed here, on the same riverbank where Steinmetz had worked out the mathematics of alternating current. 3/4 of the Navy's total turbine horsepower in the war is attributed to the company. Built in Schenectady, engineered in Schenectady, shipped from the rail yards along Erie Boulevard to the coasts and into the hulls of ships going out to both oceans. The city that had put electricity into the walls of American homes was now putting the power plants into the vessels fighting for the sea lanes. 2 miles away in the Alco erecting shops, the American Locomotive Company was doing something that would not be repeated. Between 1941 and 1944, the company built 25 Union Pacific big boys. Locomotives of a scale that had not existed before the Union Pacific asked for them and have not been equaled since. Each one stood nearly 17 feet tall and ran more than 130 feet long. Each one weighed, with its tender, in the range of 1.2 million pounds. Verify. They were articulated, hinged at the center so the frame could bend through mountain curves. Built for a single purpose, hauling freight tonnages over the Wasatch and the Laramie Ranges that conventional power could not sustain in a single pull. 25 of them. Assembled in the Schenectady erecting bays and shipped west to Wyoming and Utah, where the grades waited. The largest steam locomotives ever built in this country. The two plants ran day and night. Day and night is not a figure of speech. It is a description of shift structure, of lights burning through the dark hours over the plant floor, of men going in at midnight and coming out at 8 in the morning while the next shift was already at the gates. Schenectady was, by any measure of industrial output per square mile, one of the most important manufacturing addresses in the United States. That number, 45,000, is the summit of everything that had been accumulating since the morning in 1886, when Edison's first 200 workers came off the train. The research laboratory, the Nobel Prize, the alternating current mathematics, the ductile tungsten, the radio tower, the television signal, all of it had been building toward a production capacity that the war revealed and the peacetime economy had never quite required. Schenectady in 1943 was running at the absolute limit of what it could be. A peak built on government contracts and wartime necessity has an architecture different from the one that built it. The Navy's orders would end when the war ended. The railroads had already begun their long negotiation with diesel power, a negotiation that steam could not win. The mathematics that Steinmetz had solved for alternating current was not available for this problem. The summit was real. The summit was extraordinary. And it was the kind of summit you can only stand on once. Chapter 9. The Quiet Leaving. Then, very quietly, things began to shift. The war ended in August of 1945, and the government orders that had held 45,000 people behind the gates on Erie Boulevard began to expire with the contracts that had produced them. Military procurement does not unwind gradually. It stops. By 1950, General Electric employment in Schenectady had fallen to roughly 32,000, still an extraordinary concentration of industrial work in a single city, still enough to fill the streetcars and the lunch counters and the downtown savings banks. But something else was happening that the payroll count did not yet fully show. General Electric was building new plants, not in Schenectady, but in other states, in other countries, closer to cheaper labor, and to markets that the post-war world was opening in every direction. The company that had arrived in Schenectady because Schenectady was useful was discovering that other places were useful too. For the first time, Schenectady stopped being the only place General Electric built. 2 miles away, in the Alco erecting shops, a different mathematics was running to its conclusion. American railroads had been watching diesel locomotives accumulate advantages throughout the war years. Lower maintenance costs, cleaner operation, no water towers, no coaling stations, no ash pits to manage. The railroads converted. The conversion was not a crisis when it began, not announced as a reckoning, just a new procurement pattern appearing in the order books. Fewer steam engines, then fewer still. Then the question of whether to invest in diesel production or find a different road. The American Locomotive Company tried the different road. It never found solid ground on it. In 1968, the American Locomotive Company stopped building locomotives in Schenectady. The plant that had been making engines on that riverside ground since 1848, 120 years, longer than any living worker could claim to remember when it was not there, closed. One of the city's two pillars simply disappeared. The hall's half of the city that lights and hauls the world was gone. Not diminished, not relocated, not waiting for the next order. Gone. The other pillar was still standing, but it was no longer rooted where it had been. In 1974, General Electric moved its corporate headquarters out of New York State entirely, to Fairfield, Connecticut. The relocation was presented as an administrative efficiency. What it meant was this: the city General Electric was born in was now one plant among many on a corporate map. Schenectady was a facility. It had been home. The cuts that followed came with a name attached. In 1981, Jack Welch became chief executive of General Electric, a Massachusetts-born chemist who had built his career inside the company and had arrived at the top floor with a clear view of what he intended to do with it. Welch shed employees with such consistent aggression that the press settled on a nickname that had the virtue of precision: Neutron Jack, after the neutron bomb, the weapon designed to kill people while leaving the building standing. He shifted the company away from heavy manufacturing toward financial services and the parts of the American economy where margins were wider and balance sheets more flexible. Schenectady was not a strategic asset in that vision. It was a legacy cost, wave after wave. General Electric employment in Schenectady fell from more than 25,000 in the early 1980s to 20,000 to 15,000, to fewer still. Each announcement its own smaller headline. Each round of layoffs emptying more storefronts on State Street, more houses in the neighborhoods nearest the gates. The tax base that had built the schools and the parks and the civic institutions of a city that had believed, for 60 years, that its prosperity was structural. That base eroded year after year with the quiet insistence of water finding its level. The population followed the jobs. 95,692 in 1930, the peak. 81,682 by 1960. 77,859 by 1970. Below 68,000 by 1980, verify intermediate census figures. Decade after decade, the census handed back a smaller number than the one before. The children of the workers, leaving for the suburbs, for other states, for cities that had not staked everything on a single gate. The departure was not dramatic. It was cumulative and ordinary. A family moving to Albany, a son taking work in another state, a daughter who came home for holidays and eventually stopped coming. A city's population does not collapse. It leaves one household at a time. What remained was a city built entirely around a reason that no longer fully existed. A city whose geography was still there, whose river still ran, whose downtown blocks still stood in the grid that the payrolls had filled, but whose founding logic had departed with the company that invented it. The buildings were standing. The gates on Erie Boulevard were still there. What the streets were no longer full of was the reason they had been built. Chapter 10. What Remains? The city did not surrender the downtown to nature. That is the first fact, and it is not a small one. In the years after the layoffs accumulated into something structural rather than cyclical, Schenectady made the decision, visible in bond issues and zoning decisions, and the creation of the Schenectady Metroplex Development Authority, a public-private redevelopment body charged with filling what the industrial withdrawal had emptied, that the riverfront and the State Street corridor could be remade into something that a company town becomes when the company leaves. The Metroplex spent years assembling parcels, clearing contamination from the old industrial ground along Mohawk Harbor, and recruiting the kind of development that arrives when manufacturing has gone and tourism has not yet come. On February 8th, 2017, the same date to the calendar, on which a French and Indian war party had burned Schenectady to the ground 327 years before. Rivers Casino and Resort opened on the old industrial waterfront at Mohawk Harbor, with 1,150 slot machines and 67 table games, and a hotel above the river where freight barges had once moved. The casino brought visitors to the riverbank and jobs measured in shifts and hospitality wages, rather than in engineering patents or Nobel Prizes. A casino is not a research laboratory. It cannot replace an institution that invented the science of the power grid, or produced the first medical X-ray tube, or put a Nobel laureate to work on a Mohawk riverfront. That is not an argument against it. It is a description of the distance between what was and what is. By the 2020 census, 67,047 people lived in Schenectady, two-thirds of the 95,692 who had lived there at the 1930 peak. The number is not nothing. It is a city. But it carries in its arithmetic the full weight of what the intervening 90 years had decided, that one payroll, however extraordinary, is a foundation only as long as the company that signs it believes the address is worth keeping. The company, in a different form, is still there. GE Vernova. The successor entity spun out of General Electric, carrying the turbine and generator business that has been Schenectady's core industry since Edison's 200 workers came off the train in 1886, still builds power generation equipment on the riverfront site. Since 2023, it has put more than $130 million into the plant. New equipment, updated facilities, a commitment to the business of building the machines that move electricity through the grid. A fraction of what General Electric was here at its peak. But the turbines are still being built on the Mohawk. The research laboratory still stands. The building where William Coolidge worked out the ductile tungsten process, where Irving Langmuir solved the problem of the blackening bulb. It stands on the same ground, in the same proximity to the Mohawk. The work that came out of it crossed the century, in the bones of every medical X-ray machine and every gas-filled light bulb and every transmission line calculated from Steinmetz's equations. The gates on Erie Boulevard are still there. Not the gates of a plant running 45,000 workers in 3 shifts. Not the gates of a city whose every commercial rhythm was keyed to the crowd passing through them at 6:30 in the morning. The gates of a facility. They open and close on a few thousand workers now, where they once opened and closed on nearly half the city. The slogan, "The city that lights and hauls the world," was carved into the city's identity at a moment when it was, by any measurable standard, true. The halls are gone, the locomotive works dismantled and cleared, the erecting bays where the big boys were assembled reduced to memory and city records. The lights at reduced voltage continue. The Mohawk River runs where it has always run, along the northern edge of the old plant, past the casino at Mohawk Harbor, under the bridges that the city built when the traffic required them and has maintained since. It runs where the freight barges ran and where Steinmetz kept his houseboat in the summers. Verify. The river does not know what was built on its banks or what was lost there. It runs at the pace rivers run, carrying whatever comes off the hills. The gates are still on Erie Boulevard. In certain light, in the early morning before the shift change, they look the way things look when they have outlasted the conditions that made them necessary, present, functional, carrying the shape of what they were designed for, without the volume of what they were designed to hold. A few thousand where 45,000 once came through. The city is still there. The river is still there. The light is still on.